Now let us see example 49. This is also finding the angle between straight lines. So now you have L1 and L2 and both are given in vector form. So this is easier for us to extract out the vector. So this is V1 and back here this is V2. So after we get our V1 and V2, let's straight away apply the formula. Cos theta is equal to V1 dot V2 over magnitude V1 magnitude V2. So just do dot product, 1 times negative 2 plus 3 times 2 plus negative 4 times negative 5. And let's divide with magnitude of V1, square root of 1 squared plus 3 squared plus negative 4 squared, and also magnitude of V2, which is square root of negative 2 squared plus 2 squared plus negative 5 squared. So solve all of this by using calculator. You will get this value here. So this is for cos theta. So in order to get theta, let's use inverse cos of this value. Therefore, your theta is 34.98 degree. Now let us answer the second part of the question. If the lines are coplanar, which is in the same plane, where do these lines intersect? So in order to solve this question, we must know that when it is coplanar, the lines intersect at the point where your R1 is equal to R2. So let's equate the first line with the second line. So this is R1 in vector form, equate it with R2 in vector form. So since it is in coplanar, so we can do this, we can equate them. Now let's change all of them into parametric form. So for the I part, this is just 2 plus T1 equal to negative 1 minus 2 T2. For the J part, this is just 1 plus 3T equal to 0 plus 2 T2. For the K part, let's equate. This is negative 1 minus 4T1. This is equal to negative 2 minus 5T2. So now we have these three equations here. So what we want to do is we want to solve it simultaneously so that we can get the value of T1 and also the value of T2. So now from equation number 1, let's find T1. So T1 is just equal to, bring to another side. So your T1 is equal to negative 3 minus 2 T2. Then let's substitute this into equation number 2. Whenever you see T1, let's substitute with this value here, negative 3 minus 2 T2. And then let's solve this. You'll find your answer T2 is equal to negative 1. Then let's substitute T2 equal to negative 1 inside this equation here. So you'll have T1 equal to negative 3 minus 2 T2. So let's substitute negative 1 here. Therefore, you'll find T1 is equal to negative 1. Hence, let's substitute T1 in L1, or we can also substitute T2 in L2. So here, I'll show you where I have substituted T1 is equal to negative 1 inside line 1. So this is the equation of line 1 just now. And then let's substitute T1 as negative 1. And then open up the value. For I part, this is just 2 minus 1, which is 1. For the J part, 1 minus 3, which is negative 2. And for the K part, negative 1 plus 4, which is 3. Therefore, we have found the coordinate when it is in coplanar. Therefore, we can say that L1 and L2 intersect at this point, 1, negative 2, and 3. So this is our final answer. So that's the end of this chapter. Assalamualaikum warahmatullahi wabarakatuh.